Open SimXpert, select the Structures workspace. The first tab on the tool ribbon is the Geometry tab. In the Geometry tab, you will find tools in different groups to construct geometry. A plane can be created by using the Planer tool, where the center of the 2D geometry has to be assigned and the length and width specified. The second tab is the Meshing tab, under which you will find many different meshing tools and mesh editing tools. For 1D beam analyses, we use the Curve Mesher. For 3D geometries, we use the Solid Mesher. For plates, we use the Surface Meshing tool. The fifth tab is the Materials and Properties tab. We create materials and assign these created materials to the specific geometric elements under this tab. For 1D beam analyses, we go to the beam section library and create a beam section first, then assign that beam section with the material created to the beam's elements using the beam tool. For 3D geometries, we assign only the material to elements using the 3D properties tool. For 2D elements, we assign the material and the thickness to the elements using the shell tool. The sixth tab is the Loads and Boundary Conditions tab. Loads and boundary conditions should accurately represent real-life loads and constraints. This is very important to get right. Under the Constraints group, we will find various constraint tools to constrain the geometry. Different load cases can be assigned to the model. Now, to complete the analysis, we create a Nastran job which the solver uses to solve the current problem. Right-click on the file set and select Create New Nastran Job. The Nastran Job's location is specified when we specify the folder where the results should be saved. To monitor the solver's progress, we will view the info6 file and to determine if the analysis was completed successfully. The video in Presentation 2 Process Overview demo will illustrate this process by way of a practical example using SimXpert to solve the stresses and displacements of a complex structure. This concludes the typical FEA process we to follow in analyzing a part, structure or system using FEA. This tutorial was brought to you by STEC.